What's up, everyone? This is LeetCode 242, valid anagram. I've done this problem in Python, just so you know. So if you want to see a Python solution, it is on my channel, but this is going to be C++. So we're given two strings S and T, and we have to basically check if they're anagrams of each other and return true if they are, false otherwise. So basically, can we use all the letters in S to form the word in T? Can we use all the letters in T to form the word in S? That's basically all this problem is asking you, okay? So given that we're working with frequency of letters, right, a hash map is a good place to start, right, in terms of our approach. So let's do that. But before we even do that, we're going to handle an edge case, right? So we're going to say if s dot length, right, is not equal to t dot length, then we return false, right? Because if we have an example like this, ABA, right, we can't really form AB given only A, right? So how can these be anagrams of each other? So in cases where they're different lengths, we just automatically return false because we know for sure they can't be anagrams of each other. Okay, so in terms of the hash map, we're going to basically set the characters in a particular word as a key and the amount of times it occurs in a word as the value, right? So we're going to say st unordered, st unordered, std unordered map, and we're going to say char int. We're going to say word map. Oops, make sure you put your semicolon, otherwise we get an error. So we're going to say if word map count so basically if when we're iterating through S, because S is a string, right? If a particular character exists as a key in the hash map, then we're just going to increase the counter, okay? Else, we're going to actually set the counter to 1. If it's, because that would be the first time we encounter a specific character, right? So we handled setting the hash map up for string S. Now let's iterate through string T and make use of the hash map. So we're going to say int I is equal to 0, I is less than t dot length. Okay. So if we're going through string T now, okay? If we encounter a character in T that does not exist in S, we already know that this can't be an anagram, right? So we return false. For example, when we encounter C, the letter C and T, or the character C and T in string T, C doesn't exist in S, so just return false at that point, right? Because it can't be an anagram. Because we're never going to be able to, if C exists here but not here, how can these ever be anagrams? So yeah, T is not an anagram of S in that case. There's another edge case we have to handle, which is basically when the count is 0. Okay, so for in the else statements where we set the countdown, so we're going to say word map of t of I. So when let's go through example 1, right? So A has a value of 3, okay? So when we hit this A, it is a key in the hash map and the count is not 0, it's 3, right? So we go to the else statement and decrease the count because we basically used up 1A, right? So the value in the hash map for A, the character A would be 2 now. We hit the second A, decrease the counter, so now the value is 1. Hit this third A, decrease the counter, now the value is 0. Now let's say there's a fourth A here. That's basically where this would trigger, and we would return false, okay? Right, or for example, a more obvious example would be this, right? We have 2 C's in A, but 3 C's in T, right? That you can't use these 3 C's up here, right? Because you have 3 C's here, but 2 C's here. How does that make sense? They're not anagrams of each other in that case, right? So that's basically what that's checking. So yeah, I hope this helped. This problem really isn't that difficult. It's just you kind of have to think about some of the edge cases. That's all. That can be a little bit tricky about considering the different edge cases, but yeah, I don't think this problem is too bad. As long as you understand what your edge cases are. But anyways, I hope this helped, and I'll see you in the next one.